Good morning. Myself Prabha Ranjay, working as an assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is number representation from Unit 4, that is finite word length effect. From the subject name is digital signal processing. Let us discuss. First of all, we should know about what is mean by number system, number representation. In DSP, digital signal processing, a number capital N can be represented to any desired format using number system to represent the numbers in any digital hardware. okay Let me discuss about the types of number system. There are two types of number system. First one is um, fixed point representation, another one is floating point representation, and next is uh, discuss about the register word length. Before that, we should know about what is mean by register. The register are the basic storage device in digital system. The maximum size of the binary information or binary data that can be stored in register is called register word length. For example, when a register stores an 8-bit data, then its word length is 8-bit. Okay, fine. Okay, next is finite word length effect. The register is used to store the result is 8-bit 8-bit data, then the result has to be truncated or rounded. Truncated or rounded in means, which means quantization process to accommodate in the register. This makes the system which is non-linear, leads to limit cycle behavior. The effect of truncation and rounding can be represented in terms of an additive error signal, which is called round of noise. This effect due to finite precision representation of numbers in a digital system are commonly referred to as finite word length effect. Next, we will discuss about the error of the number system. okay. Uh, we will see the what are the error is possible in this number system in this finite word length effect. First one is errors due to quantization of input uh, by ADC, which means analog to digital conversion. Error due to quantization of filter coefficient. Error due to rounding the product on multiplication. Error due to overflow in addition, and finally is a limit cycle oscillation. Okay. Next one is what is mean by binary codes. The binary codes are framed using the numeric symbols zeros or and 1. Each digit of the binary code is called bit. The size of the binary code is specifies in terms of number of bit. In digital system, the binary codes are used to represent any information like text, image, numbers, etc. When decimal numbers are represented in binary codes, the size of the code will decide the range of numbers that can be represented in binary. And already these are next fixed point representation, floating point representation. The floating point representation is employed to represent large range of the numbers in a given binary word size. The floating point representation as n equal to m into 2 power e. And next is in fixed point representation, there is only one unique way of representing positive binary fraction, which is represented by capital N suffix p equal to 0. Decimal value 1 to etc d power d suffix b, which is represented as, which is denoted as sum of I equal to 0 to capital B d suffix I 2 power minus I. This is for the positive binary fraction number for fixed point representation. And then sign magnitude format, the sign negative binary fraction, the sign magnitude format for negative binary fraction, which is equal to positive represented as 0 and negative represented as 1, 1 into 2 power 0 plus sum of I equal to 1 to b digit d suffix I position of the digit 2 power minus I. This is for the negative number. For positive number, which is represented by 0. 0 is nothing but the positive number, and 1 is nothing but the negative number. Also, the range of decimal fraction number that can be represented in capital B bit fixed point sign magnitude format is range from minus 1 minus 2 power minus b minus 1 to plus 1 minus 2 power minus b minus 1, with step size 1 divided by 2 power capital B minus 1. And next is, let me do one small activity. You can see from the first diagram, um, find the value for fourth column value from the first column value of the first column and value of the second column. Comment me for the correct answer. And next one is uh, uh, likewise, you can find the you can see here, you can see the 3 hen which is equal to 60 and 1 hen plus 2 plate of egg equal to 26, and uh, one plate of egg and two group of banana which is equal to 15. What is the value of, to find what is the value of one hen and one plate of egg and one group of banana values? Correct answer, give me comment. Let me see. Okay, continue the lecture. And next is ones complement. The ones complement format is complement of digit which is equal to 1 minus di. And then negative binary fraction number in ones complement equal to 1 into 2 power 0 plus sum of I equal to 1 to b 1 minus d suffix I 2 power minus I. This is the formula for the ones complement. And likewise, two's complement. For two's complement, you have to take ones complement for that number. After that, to add the least significant bit for 1. This is the two's complement. And finally, we will discuss the floating point representation, which is equal to, floating point is represented by n suffix r, which is equal to capital M into 2 power capital E. M is called mantissa and it will be in binary fraction format. The value of M will be in range of M greater than or equal to 0, less than or equal to 1, and E is called exponent, and it is either positive or negative integer. Then in floating point representation, both mantissa and exponent uses 1 bit for representation sign. Usually the leftmost bit in mantissa and exponent is used to represent the sign. One is the rightmost bit position represent negative sign, and 0 is the leftmost bit position representing positive sign. Um, in floating point representation is explained by considering a 5-bit mantissa and 3-bit exponent with a total size of uh, 8-bit. Here you can see, in mantissa the leftmost bit is used to represent the sign, and the other 4-bit are used to represent a binary fraction number. In exponent, the leftmost bit is used to represent the sign, and other 2 bits are used to represent a binary integer number. Next, this is the assessment for this lecture. First is define register word length. You have to define the what is mean by register word length. Next is what is mean by round of noise, and then summarize the finite word length effect in digital filter. How to represent any number in radix number system. List the two methods of representing a binary numbers. Mention 3 different format for representing negative binary fraction number. Also, and final question is define floating point representation. These are the assessment questions. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.